Hello guys, thanks for coming back again if you have subscribed. If you are yet to subscribe, don't miss out our videos. Click on the subscribe button and also on the bell beside it. That will notify you when we drop our new video. Thank you. Now we want to look at this function that is probably able to satisfy this expression. Now we know that this is apparently untrue, which means it is not really true. So let's test that, because if we have a function y equals 2x squared, we all know that the derivative of this function, which is the y dx, is going to be 4x. And the second derivative, which is d squared y dx squared, is going to be 4. So according to this equation we have here, it's telling us that the second derivative equals the first derivative squared. And that is not real, but actually, if we're going to test that with this, we would see that the square of this does not give this. So which means this gives us 16x squared, and that is not equals to 4. But however, is there any function that will satisfy this expression? Let's think of how to get such function mathematically. Okay, let's look at the approach we can take in order to get such function. So how possible is that? Let us use this idea. Let u equals dy dx. If u is dy dx, don't forget this expression here means d dx of dy dx. That is the derivative of the first derivative. Then equals dy dx all squared. So if I say u is dy dx, that means I am having du dx, since this is u, is equals to u squared. Now I have to integrate, then applying the variable separable method in solving my differential equation. So which means if I have du equals u squared dx, then using the principle of variable separable, I can actually multiply both sides by 1 over u squared. So if I multiply this by 1 all over u squared, and I multiply this by 1 over u squared, so what am I going to have? I'm going to have 1 all over u squared du equals dx. So the next step is to integrate both sides. So if I integrate this side, you know what I'm going to have? I'm going to have u raised to the power minus 1 negative u raised to the power minus 1 all equals. If I integrate this, don't forget we have to add a constant c. So let's call that the constant c1, so that when we integrate this side, we are going to have x plus c. Actually c2. So if this is the case, what next? Let us make use of this now, and I have negative 1 all over u. I think this is what I have, plus c1 equals x plus c2. Bringing the constant together to have just 1, I'm going to have negative inverse of u all equals x plus c2 minus c1. Actually, you know that constant minus constant is also leading to a constant, so I can have minus 1 over u equals x plus c3. So let's have this. That is the first step. Then we are yet to find the equation. Don't forget u is the y dx, so which means we still have a derivative in this function. So then we still have to integrate one more time to evaluate to evacuate the differentiation, the differential coefficient, and get our function. So now let's get rid of this. So I haven't gotten this. What next? Then I think I have to go back to what I have. So I have negative inverse of u equals x plus c3. So which means the negative inverse of dy dx is equals to x plus c3. And apparently you know that what we have here is going to give us negative dx over dy equals x plus c3. Okay, I'll keep it up from here. So after this, what next? Let us solve our differential equation. So if I have negative dx equals x plus c3, dy, then what next? I can actually divide both sides, or probably multiply both sides by 1 over x plus c3, and which is the same thing as dividing both sides by x plus c3, x plus c3. So which means this goes with this. And at the same time, I have negative 1 all over x plus c3 dx all equals dy. Now I can integrate once again. So if I integrate this side, don't mind my integral looks like snake, so let's take this and this. So if I integrate this side, actually I'm supposed to use a series of different integration, but using the rule that if you differentiate the denominator and it gives you the numerator, which is 1, I think x will give 1 and this will give 0. If I differentiate c3, which is a constant, it will give me 0. If I differentiate s, it's going to give me 1, so which means I'm going to have 1 plus 0, and that is going to give us 1. But don't forget the power, the numerator here is negative 1. So which means the integral of this is the negative inertial of x plus c3. Don't forget plus c. Let me make that c4. All equals, the integral goes with this d, and I have y plus c. So bringing c5 actually, so let me bring all these constants together. So I'm going to have the negative inertial of x plus c3, then plus c4 minus c5 actually, all equals y. So which means c4 minus c5 also gives constant. So what next? I'm going to have the negative inertial of x plus c3, then plus c6 all equals y. Actually, we don't know the value of c6. C6 might be any constant. So, and there are different techniques you can use to find your c6 and c3 actually. So, which means the function that will satisfy this expression is given as this authentic function. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.